Picture yourself gazing up at the night sky and witnessing something extraordinary, a colossal, brilliantly colored structure so immense it could swallow hundreds of solar systems whole. These magnificent cosmic formations are nebulae, the true stellar factories of our universe. Within their swirling depths, the building blocks of everything we know come together in a cosmic dance that has persisted for billions of years. These celestial marvels paint our cosmos with stunning hues of red, blue, and purple, stretching across light years of space like ethereal cosmic clouds. But nebulae are far more than just celestial artwork. They are the cosmic nurseries where stars are born, the recycling centers where dying stars scatter their elements across space, and the very reason we exist at all. Every atom of iron in your blood, every calcium molecule in your bones, and every trace of carbon in your cells was once part of these majestic cosmic clouds. As we embark on this journey together, we'll unravel the mysteries of how these incredible cosmic structures form and evolve. We'll discover why astronomers consider them the most crucial factories in the universe, crafting the very elements that would eventually form planets, moons, and even life itself. From the vibrant red glow of emission nebulae to the ghostly blue reflections of stellar light off cosmic dust, each nebula tells a unique story of creation and transformation. These vast cosmic clouds are silent witnesses to the endless cycle of stellar birth and death, playing a fundamental role in the cosmic story that led to our own existence. They remind us that we are all connected to these distant celestial phenomena in the most intimate way possible, through the very atoms that make up our bodies. Today, we'll explore how these magnificent structures form and why they remain essential to the continuing story of our universe. Let's venture into these cosmic depths together and uncover the extraordinary processes that transform simple clouds of gas and dust into the birthplaces of stars and solar systems. What we're about to discover will forever change how you look at the night sky and your place in the cosmic tapestry. What you're about to discover will fundamentally transform your understanding of the cosmos, taking you on a journey through one of the universe's most captivating phenomena. In the next few minutes, we'll delve deep into the intricate processes that govern nebula formation, unveiling secrets that have fascinated astronomers for centuries and continue to reveal new mysteries with each technological advancement. Through the lens of modern astronomy and cutting-edge space telescopes, we'll explore how these vast cosmic clouds serve as nature's most spectacular workshops. You'll witness how simple atoms of hydrogen and helium, along with microscopic dust particles, come together under the influence of gravity to orchestrate one of the universe's most magnificent shows, the birth of new stars. These celestial nurseries, as astronomers affectionately call them, are far more dynamic and complex than they appear in even the most stunning photographs. Within their depths, countless dramatic events unfold simultaneously. Massive gas clouds collapse under their own weight, protostars ignite in brilliant flashes, and powerful stellar winds sculpt the surrounding space into ethereal shapes that captivate our imagination. As we explore these stellar nurseries, you'll understand why they're not just beautiful cosmic spectacles, but also crucial laboratories where we can observe the processes that shaped our own solar system billions of years ago. Every star you see in the night sky, including our sun, was once cradled within the depths of a nebula. This realization connects us directly to these distant cosmic clouds, making their study not just an exercise in astronomical observation, but a journey to understand our own cosmic origins. The knowledge you'll gain about these celestial incubators will forever change how you perceive the night sky. You'll no longer see just points of light or colorful clouds. Instead, you'll recognize these regions as the dynamic, living spaces where the future of our galaxy is being written, one star at a time. Nebulae stand as some of the most majestic structures in our cosmos, appearing as vast clouds of gas and dust drifting through the depths of interstellar space. To truly grasp their immense scale, consider the famous Orion Nebula, one of the most studied celestial objects in our night sky. This cosmic giant stretches approximately 15 light-years across, a distance so vast that it challenges human comprehension. To put this in perspective, light, traveling at an astounding speed of 300,000 kilometers per second, would take 15 years to traverse from one end of this nebula to the other. These celestial formations consist primarily of hydrogen and helium, the most abundant elements in the universe, along with scattered cosmic dust particles. The gas in these cosmic clouds is incredibly thin, far less dense than any vacuum we can create on Earth. Yet, despite their ethereal nature, nebulae contain enough material to forge thousands of stars like our Sun. Their seemingly delicate appearance belies their role as the universe's most productive stellar factories. The space between stars, once thought to be completely empty, is actually populated by these extraordinary structures. They exist in various sizes and shapes, from compact planetary nebulae spanning just a few light-years to gigantic molecular clouds extending hundreds of light-years across our galaxy. The interstellar medium, where these nebulae reside, serves as a cosmic recycling system where matter from dying stars becomes the raw material for future stellar generations. Understanding the basic nature of nebulae provides us with crucial insights into the cosmic processes that shaped our own solar system. When we observe these magnificent clouds through powerful telescopes, we're not just witnessing distant astronomical objects. We're looking at the very same type of stellar nursery that gave birth to our Sun roughly 4.6 billion years ago. This connection makes nebulae not just objects of scientific study, but direct links to our own cosmic heritage. In the vast theater of space, nebulae emerge through distinct formation processes, each creating unique and spectacular cosmic displays. According to leading astronomers at major observatories worldwide, including prominent researchers at the European Southern Observatory, there are two primary mechanisms through which these celestial formations come into existence. The first formation process occurs when massive stars reach the end of their lives in spectacular fashion. When these stellar giants exhaust their nuclear fuel, they undergo tremendous explosions known as supernovae, violently expelling their outer layers into space. This explosive process creates what we call supernova remnants, a type of nebula that expands outward into the surrounding space at incredible velocities, sometimes exceeding tens of thousands of kilometers per second. The Crab Nebula, located approximately 6,500 light-years from Earth, stands as one of the most famous examples of this formation type. The second major formation process involves the gradual accumulation of gas and dust in the interstellar medium. Over millions of years, gravitational forces draw together dispersed material in space, forming enormous clouds that eventually become dense enough to be classified as nebulae. These structures, often called molecular clouds or dark nebulae, can remain relatively stable for millions of years before external forces trigger their evolution into star-forming regions. Interestingly, these formation processes aren't mutually exclusive. They often interact and influence each other. For instance, the shock waves from a supernova explosion can compress nearby molecular clouds, triggering the formation of new stars and consequently new emission nebulae. This interconnected nature of nebula formation demonstrates the complex and dynamic nature of our universe, where the death of one cosmic structure often leads to the birth of another. The timing of these formation processes varies dramatically. While supernova-induced nebulae can form in a matter of hours or days, the gradual accumulation of material in molecular clouds can take millions of years. This diversity in formation timescales contributes to the rich variety of nebula structures we observe throughout our galaxy, each telling its own unique story of cosmic evolution and transformation. Emission nebulae represent some of the most spectacular light shows in our universe, created through a fascinating process of stellar interaction and atomic physics. Picture an enormous cloud of primarily hydrogen and helium gas, peacefully drifting through the cosmic void. This serene scene dramatically transforms when a young, extremely hot star emerges in its vicinity. These youthful stars, typically massive O-type or B-type stars with surface temperatures exceeding 25,000 Kelvin, become the cosmic architects of emission nebulae. Their intense ultraviolet radiation penetrates the surrounding gas clouds with tremendous energy. When this high-energy radiation collides with the hydrogen atoms in the nebula, it strips electrons from their atomic nuclei, creating what astronomers call ionized hydrogen, or HII regions. The magic truly happens during the recombination process. As free electrons reunite with ionized hydrogen atoms, they cascade through different energy levels, releasing precise amounts of energy in the form of light. This process produces the characteristic deep red color that dominates emission nebulae, specifically at a wavelength of 656.3 nanometers, known as H-alpha emission. This distinctive red glow has become a signature feature of emission nebulae, making them easily identifiable through telescopes. But the color story doesn't end with red. Different elements within the nebula produce various colors when ionized. Oxygen, for instance, can create beautiful blue-green hues, while nitrogen might contribute subtle purple tints. The famous Orion Nebula exemplifies this cosmic palette perfectly, displaying a rich tapestry of colors that reveal its complex chemical composition. The process remains dynamic and ongoing. As the stellar radiation continues to energize the gas, new regions become ionized while others recombine, creating a constant state of flux. This perpetual cycle of ionization and recombination transforms what would otherwise be invisible gas clouds into brilliant cosmic beacons, visible across thousands of light years. Through this process, emission nebulae not only create spectacular celestial displays, but also provide astronomers with valuable information about stellar evolution and the chemical enrichment of our galaxy. Reflection nebulae represent one of nature's most elegant displays of cosmic illumination, serving as celestial mirrors that capture and reflect the light of nearby stars. Unlike their emission counterparts, these nebulae don't produce their own light, but instead perform a sophisticated dance of light scattering that creates their characteristic blue hues. At the heart of a reflection nebula lies a delicate interplay between starlight and cosmic dust. These dust particles, typically consisting of carbon, silicon, and other elements, are incredibly tiny, measuring just a fraction of a micron across. When light from nearby stars encounters these microscopic particles, something remarkable happens. Through a process known as Rayleigh scattering, the same phenomenon that makes our sky appear blue, shorter wavelengths of light are scattered more effectively than longer ones. This selective scattering creates the stunning blue appearance that characterizes most reflection nebulae. The Pleiades star cluster offers one of the most spectacular examples of reflection nebulae in our night sky. Also known as the Seven Sisters, this stellar grouping is surrounded by wispy blue nebulosity that seems to envelop its bright stars like a cosmic veil. The dust particles in this region act as billions of tiny mirrors, redirecting the starlight from the hot, young stars within the cluster toward Earth, creating an ethereal blue glow that extends across several light-years of space. Temperature plays a crucial role in determining the appearance of reflection nebulae. The stars illuminating these cosmic clouds must be hot enough to shine brightly, but not so hot that they ionize the surrounding gas, as this would transform the nebula into an emission nebula. This delicate balance typically occurs with stars of spectral types A or B, whose surface temperatures range between 10,000 and 25,000 Kelvin. Perhaps one of the most fascinating aspects of reflection nebulae is how they reveal the complex structure of interstellar space. As starlight bounces off different layers of dust, it creates intricate patterns of brightness and shadow that astronomers can use to study the distribution of material in these regions. These studies have proven invaluable in understanding how matter is distributed throughout our galaxy and how it influences the formation of future stars and planetary systems. Observing these cosmic mirrors provides us with more than just aesthetic pleasure. They offer crucial insights into the evolution of stellar nurseries and the cycle of stellar birth and death. As we continue to study these beautiful blue apparitions with increasingly sophisticated telescopes, each observation adds another piece to our understanding of the complex processes that shape our universe. If you find yourself as captivated as I am by these cosmic stellar factories, I invite you to join our growing community of space enthusiasts. By subscribing to our channel, you'll ensure you don't miss any of our future explorations into the mysteries of the cosmos. The life cycle of nebulae represents one of the most dramatic and consequential processes in our universe, weaving a complex tale of cosmic evolution that spans billions of years. These celestial structures are far from static. They're dynamic entities that transform continuously, participating in an eternal cosmic dance of creation and destruction. At the heart of nebula evolution lies a fascinating cycle that begins with vast clouds of primordial gas, primarily hydrogen and helium left over from the Big Bang. These molecular clouds can remain relatively stable for millions of years until something disturbs their delicate equilibrium. This disturbance might come from a nearby supernova's shockwave, the gravitational influence of passing stars, or the spiral arms of our galaxy sweeping through the region. When these clouds begin to collapse under their own gravity, they fragment into smaller clumps, each potentially becoming a stellar nursery. Within these nurseries, the density increases, temperatures rise, and new stars ignite. This process transforms what was once a dark nebula into an emission or reflection nebula, depending on the temperature and brightness of the newly formed stars. But perhaps the most spectacular chapter in a nebula's life cycle occurs through the dramatic death of massive stars. When these stellar giants exhaust their nuclear fuel, they explode as supernovae, violently expelling their outer layers into space. These explosions create expanding shells of gas and dust that we observe as supernova remnants, a special class of nebulae that marks both an end and a beginning in the cosmic cycle. Leading astronomers in the field, including renowned astrophysicists from major research institutions, emphasize the crucial role of these stellar explosions in cosmic evolution. These cataclysmic events forge and disperse heavy elements, including carbon, oxygen, iron, and gold, throughout space. This process, known as stellar nucleosynthesis, is quite literally responsible for creating most of the elements heavier than helium in our universe. The expelled material from these dying stars doesn't simply dissipate into space. Instead, it becomes part of the interstellar medium, eventually mixing with existing nebulae or forming new ones. This enriched material will ultimately participate in forming the next generation of stars and planets. It's a profound realization that the atoms in our bodies, the calcium in our bones, the iron in our blood, and the carbon in our cells were all created in the hearts of stars and distributed through space by these nebular processes. Recent observations from advanced telescopes have revealed even more complexity in this cycle. We now understand that nebulae can interact with each other, merge, and be torn apart by gravitational forces. Some nebulae persist for millions of years, while others disperse relatively quickly. The famous Crab Nebula, for instance, has been expanding since its formation in a supernova explosion witnessed by astronomers in 1054 CE and continues to evolve before our eyes. Studying these life cycles has become increasingly sophisticated with modern technology. The James Webb Space Telescope and other advanced instruments are revealing unprecedented details about nebula evolution, showing us how these processes vary in different environments and under different conditions throughout our galaxy and beyond. This continuous cycle of nebula evolution, from the collapse of gas clouds to the formation of stars, and from stellar deaths back to nebula birth, represents one of nature's most efficient recycling systems. It ensures that the universe continues to evolve, creating the conditions necessary for the formation of new stars, planets, and potentially life itself, in an endless cycle of cosmic renewal. The realm of nebulae holds some of the most fascinating and mind-bending facts in astronomy, connecting our daily existence to the cosmic drama unfolding in the depths of space. One of the most remarkable revelations is the direct link between our physical bodies and these distant cosmic clouds. Every atom of calcium that forms your skeletal structure was quite literally forged within ancient nebulae through stellar nucleosynthesis billions of years ago. This cosmic connection goes even deeper. The iron in your blood, the carbon in your DNA, and the oxygen you breathe were all created within stellar furnaces and distributed through space via nebula processes. When you look at your hand, you're actually observing matter that was once part of several different stars and nebulae. This realization transforms our understanding of our place in the universe. We are, in the most literal sense, made of stardust, processed through nebula recycling. The sheer scale of nebulae challenges our earthbound comprehension. The famous Eagle Nebula, for instance, spans approximately 70 light-years across. To put this in perspective, if our solar system were the size of a quarter, the Eagle Nebula would cover an area larger than North America. Within these vast cosmic clouds, the amount of matter is equally staggering. A single nebula can contain enough material to form thousands or even tens of thousands of stars like our Sun. Consider the Orion Nebula, one of the most studied stellar nurseries in our galaxy. This single structure contains enough mass to create over 10,000 stars similar to our Sun. The nebula's central region alone harbors a cluster of about 2,800 stars, and astronomers estimate that it's actively forming hundreds more. This productivity demonstrates why nebulae are often called the factories of the cosmos. Temperature variations within nebulae present another fascinating aspect. While parts of a nebula might be incredibly cold, approaching 260 degrees Celsius in the darkest regions, other areas near newly formed stars can reach temperatures of several thousand degrees. This temperature diversity creates unique chemical and physical conditions that influence star formation and the evolution of planetary systems. The longevity of nebulae adds another layer of wonder to their story. While some nebula structures are relatively short-lived, lasting only a few 100,000 years, others persist for millions of years. The Great Nebula in Carina, for example, has been actively forming stars for at least 3 million years and shows no signs of stopping. This extended timeline allows multiple generations of stars to form within the same nebula complex. Perhaps most surprising is the discovery that nebulae are not just passive clouds in space. They are dynamic systems that respond to their environment, contracting and expanding based on various forces. Some nebulae even produce their own magnetic fields, which can influence their shape and evolution. The Crab Nebula, for instance, generates a magnetic field so powerful it produces visible light through synchrotron radiation. The chemical complexity within nebulae continues to astonish scientists. Recent studies have detected complex organic molecules, including some of the basic building blocks of life within certain nebulae. This suggests that these cosmic clouds might play a role not just in creating the elements necessary for life, but in initiating some of the chemical processes that could lead to life itself. These celestial giants also serve as natural laboratories for studying physics under extreme conditions impossible to replicate on Earth. The processes occurring within nebulae help us understand fundamental aspects of matter, energy, and the forces that shape our universe. Each new observation reveals more surprises about these extraordinary cosmic structures, reminding us that we've only begun to uncover their secrets. The impact of nebulae on modern astronomy has been nothing short of revolutionary, particularly since the deployment of the James Webb Space Telescope. This incredible space observatory has transformed our understanding of these cosmic structures, providing unprecedented views into the processes that drive nebula formation and evolution. The James Webb Space Telescope's advanced infrared capabilities have allowed astronomers to peer through dense cosmic clouds that were previously opaque to visible light, revealing intricate details about nebula structure and composition. These observations have shown us that nebulae are far more dynamic and complex than we previously imagined. The telescope's near and mid-infrared instruments have captured stunning images of stellar nurseries within nebulae, showing us the precise moments when new stars burst into life. Modern astronomical observations have revealed previously unknown features within familiar nebulae. For instance, the Webb telescope's examination of the Carina Nebula uncovered hundreds of previously hidden stars and numerous bubble-like structures created by the intense radiation of young, massive stars. These discoveries are helping astronomers better understand the mechanisms that control star formation and the complex interplay between stellar radiation and nebula gas. Recent observations have also provided new insights into the chemical evolution of nebulae. The advanced spectroscopic capabilities of modern telescopes have detected complex organic molecules within these cosmic clouds, suggesting that the chemical foundations for life might be more common in the universe than previously thought. Each new image and data set reveals increasingly intricate processes at work within these stellar nurseries. The resolution and sensitivity of modern instruments have allowed astronomers to study nebulae in unprecedented detail. We can now observe the delicate filaments of gas shaped by stellar winds, track the movement of material within nebulae, and witness the formation of protoplanetary disks around newly formed stars. These observations are crucial for understanding not just how stars form, but how entire planetary systems, including those that might harbor life, come into existence. Perhaps most significantly, modern astronomical techniques have revealed that nebulae play an even more crucial role in galactic evolution than previously understood. We now know that these cosmic clouds are not isolated entities, but are interconnected through complex networks of gas and energy that span entire galaxies. The processes occurring within nebulae influence the chemical composition and structure of their host galaxies, making them key players in cosmic evolution. The Webb telescope's observations have also challenged some of our existing theories about nebula evolution. Its detailed images have shown that star formation can occur in ways we hadn't anticipated, and that the interaction between young stars and their surrounding nebula material is more complex than our models had predicted. Each new discovery pushes us to refine our understanding of these cosmic phenomena. As our technological capabilities continue to advance, we find ourselves at the threshold of even greater discoveries. The combination of modern space telescopes, ground-based observatories, and sophisticated computer modeling is providing us with an increasingly detailed picture of these cosmic clouds. These advances are not just expanding our knowledge, they're revealing new questions and mysteries that will drive astronomical research for decades to come. As we conclude our journey through the magnificent realm of nebulae, we find ourselves humbled by the profound realization that these cosmic structures are far more than just colorful smudges adorning our night sky. They represent the very essence of cosmic creation and transformation, where the past and future of our universe converge in an eternal dance of destruction and rebirth. In these vast cosmic clouds, we witness the complete story of stellar evolution unfolding before our eyes. Here, the remnants of ancient stars mix with pristine gas to forge new generations of stellar objects. This perpetual cycle of cosmic recycling ensures that the elements created billions of years ago continue to find new purpose in forming future stars, planets, and perhaps even the building blocks of life itself. The study of nebulae has revolutionized our understanding of our place in the cosmos. These celestial factories have shown us that we are intimately connected to the stars, not just as distant observers, but as direct descendants of the stellar processes that occur within these cosmic clouds. Every atom in our bodies tells a story that began in the heart of a nebula, making us living testimonies to the creative power of these astronomical wonders. As we gaze upon these cosmic nurseries, we're not just seeing distant objects millions of light years away. We're observing our own origins and the future of our galaxy in action. The same processes that we study in nebulae today are responsible for creating the elements that would eventually form our solar system, our planet, and even ourselves. This profound connection transforms these distant cosmic structures from mere astronomical objects into crucial chapters in our own cosmic story. And now, as we bring this exploration to a close, I invite you to continue this fascinating journey of cosmic discovery with us. If you found yourself captivated by these incredible cosmic structures and wish to delve deeper into the mysteries of our universe, I warmly encourage you to become part of our growing community of space enthusiasts by subscribing to Exploring the Universe. By joining our channel, you'll ensure you don't miss any of our future explorations into the cosmos. From the birth of stars to the death of galaxies, from mysterious black holes to the enigmatic dark matter, we'll continue to unravel the universe's greatest mysteries together. Your subscription helps support our mission to bring the wonders of the cosmos closer to home and make complex astronomical concepts accessible to everyone. Don't forget to show your appreciation by leaving a like on this video if you've enjoyed our journey through the world of nebulae. Your engagement helps us reach more curious minds and spread the wonder of astronomical discovery to an even wider audience. Share this video with friends and family who might be interested in learning more about these fascinating cosmic structures. Together, we'll continue our quest to understand our place in this vast cosmos, one astronomical wonder at a time. The universe is filled with countless mysteries waiting to be explored, and we're thrilled to have you join us on this endless journey of discovery. Until our next cosmic adventure, keep looking up and wondering about the magnificent universe that surrounds us.